I would never start. If I got F on it,
You didn't get an F.
I got A.
Oh, that might be in jeopardy. I don't think you got anything lower than B,
I mean, if it's a B,
but you definitely made some mistakes.
that's why I didn't go for it.
Did you curl your hair today?
No, I took the braids out from yesterday.
You're lucky that I even noticed. I usually don't notice things, but I'm like that.
I'm used to guys not noticing. My brothers and my dad.
All right, hey, listen up.
Yeah, I know.
Listen up. So I'm not done grading with the test. I think I got one page left. I'll just say, adding and subtracting, we have many people, in the sense of many mean like at least 5 or 6. That means many. We have many people that truly don't have a clue on adding, subtracting fractions. Okay? We aren't teaching it again. You will know as soon as I hand you back your test that, yeah, you're right, I don't know how to add, subtract. The multiplying, dividing, I got plenty. There's 1 or 2 people that are still a little lost in that. But I just have too many people that don't know how to add and subtract. If you're one of those persons and you do nothing about it, nothing's going to get better. We're going to be adding and subtracting fractions starting tomorrow. Again, you may know how to solve equations, but as soon as you get to one with fractions, you get it wrong because you still don't know how to add and subtract fractions. Please see me for tutoring. Let me help you, right? It won't get any better, trust me. Algebra, nearly every problem in algebra is a fraction of some sort. So fractions don't go away. And it's also not something that any Algebra 1 or higher teacher ever spends any time on. Hey, remember, get a common denominator. This is how you make equivalent fractions. It never happens again, ever. You're done with it for the rest of your life. Except if you come to tutoring, then we got to do it again. So please seek help for those that did poorly on that part. All right, any questions on the homework? Yes?
Number 26.
Oh, and Jace is not a robot. He didn't get a perfect paper. I'm sure he's going to get an A, but he didn't get a perfect paper. You worry about your grade. All right, Jace, which one? Let's take a look at 26. Hey, it's got a fraction. What do you know? So 26 starts as follows. It says -5, that's how I know we're in course 2 because I have negative numbers, is equal to t plus 6 1/3. Okay, Mr. C's rules, or guidance I should say, is that whenever you have a mixed number, generally speaking, I just change it to an improper fraction. This is me, right? Some of you are still not giving me full compliance, and you're saying I don't need to do that. I can leave it as a mixed number, and I can add and subtract. Great for adding, and then all of a sudden you get to subtracting, and you screw it up. Subtraction is that thing that involves this thing called borrowing. And when you need to subtract a larger number from a smaller number, you run into problems because then you don't know what to do. If you leave it as an improper fraction, you will know what to do. In this case, that's what we got to do. We got to subtract 6 1/3 from both sides. Let's change it to a mixed number. So this will be -5 is equal to t plus 19 over 3. What's attached to t? How do we get rid of plus 19 over 3? We subtract 19 over 3 from both sides. Ugly. I need scratch work because I got fractions. So what does this say right here? It doesn't say 5. -5 minus 19 over 3. Scratch work. So -5 minus 19 over 3. Well, you got to put it over 1. Get common denominators. What's the common denominator? Well, common denominator is 3. The equivalent fraction is -15 over 3. We okay, Jace? Yeah. Same or different signs? So add or subtract. Okay, so add those numbers. 20, 34, what? Negative 34 over 3. No, you're right. It's negative 34 over 3. So we get, okay, now I'm over here. So we got negative 34 over 3 equals T. And we're done because I said, unless it specifically says write things as a mixed number, don't change it. If you want to write that as a mixed number, that's what? 11 and 1/3, is that right?
Yeah.
Negative 11 1/3, down correct. All right. So fractions aren't going away. They're here for good. All right, no other questions? Here we go. Number 2. Now, the correct way to answer any equation that you solve is variable equals number. Okay? So if you look in the back of the book and they don't do that, then they will eventually. P equals 9, number 2. Number 4, N equals negative 5. Number 6, A equals 25. Number 8, D equals negative 34. Number 10, G equals 28. Number 12, Q equals negative 17. Number 14, L equals 23. Number 16, K equals negative 21. Number 18, N equals 17. Number 20, H equals negative 39. Number 22, B equals 46. Number 24, W equals 1. Number 26, we just said it. You can either put negative 34 over 3 or negative 11 and 1/3. And then number 28, K equals 11.3. And 30, F equals 6.5. David. 17, negative 39, and 46. 6 was 25. Okay, I will only give you one warning. Look at your paper right now. Look at your paper right now. Look at your paper right now. Maybe the first year this never happens. Darn it. Darn it.
Did I not do it right?
Well, I was going to make a statement that if your paper looks like, oh, thank God, one person. If your paper looks like this, tomorrow I will ask you to tear it up and throw it away. Why is this wrong and this one's right? There's no work on it.
Shut up.
Right?
I
So
was trying to hurry.
tomorrow I will absolutely, when we get to multiple step equation, there's no person that can write the answer. They don't exist. Okay? With one step equation, you can certainly look at the question and come up with the answer. Maybe not on the last couple ones, those are challenging. But if you just have answers, you're not doing it. You're either copying off someone else or you're not doing the work. So that's your only warning. All right. Somebody collect. Grayson, grab the box that has course 2. Collect and pass out. Usually I have more than one person. No, that does that. And last year it was Christian. This time at least Christian did his work. Good job, Christian. All right. We have nothing until next. Wow, we got a long time to go before the quiz. All right. The quiz will be on 2-step equations. But we'll talk about it more next week. What was he doing? He took his what?
He looked like he was depressed.
I think he's a little depressed right now because his room's being used for.
No,
That's not the reason.
So he got
It wa-
and some of the second graders said if
They wouldn't care.
if you were
Well, that's kind of mean.
Yeah.
Yeah, and
How do you guys already know about this?
I don't.
There's only been one class. I know there's been 2 classes. Oh, never mind. I thought this was period 2. I just remembered it's period 3.
That wasn't us.
Yeah, that's me.
Yeah, we were. Yeah, we were. We were good there.
I'll check in with him, make sure he's okay.
He was always trying to get Jane or Jeopardy.
Yeah.
Yeah, he didn't say anything for the whole entire class period.
They said earlier.
I'll check it. All right.
All good.
So this is the last class where I literally have to say, hey, suspend your unwillingness to do work, because as soon as we get to 2 steps and beyond, then you're going to show work because you got to. Right? But 1-step equations, once again, you certainly can look at typically the problem and come up with the answer. So I'm going to show you the method to solve 1 steps by multiplication and division. If you already know what you're doing, now be careful with the fractions. But if you already know what you're doing, obviously you can get started in homework. All right, so I did say, though, that for the next 3 days in a row, you're going to write down the rules. You're going to write down the key ideas. And on the 4th day, I'm going to pick someone at random. And if you can say it, then we won't write it down again. All right. Remember that when we talk about equations, we split the equation in, it's bad math words, but in half, right? The equal sign is the middle point, even though it physically might not be the middle point. Computationally wise, it is the middle point. This breaks the equation into the left side, the right side. So you'll hear me say, what side is the variable on? Hey, what's the answer to what side the variable is on this one? What's the answer? Where's the variable, left or right side? It's on both. Boy, we have to come up with a new technique to solve that one. This is Tuesday or Wednesday next week. All right. Because remember, we got a 3-day weekend.
Oh, yeah.
All right. And we're going to be talking continuously about these things called algebraic equations. Algebraic equations are equations that have 1 variable. This year, you'll see ones with 2 variables. And we'll talk about how to solve those in a chapter or 2 from now. But not this chapter, we're only going to see 1 variable. You could have it on both sides, but it'll just be X or Y or Z or P, Q, whatever. All right, equations say that the left side equals the right side. Algebraic equations say the same thing, except it throws in 1 or 2 or 26 variables. Okay? So that's an algebraic equation. It's got 1 variable, but you can certainly have one that has 2 variables as well, too. All right, write this down, please. Just in red. Everyone write this down. You must have this memorized. All right. The 3 key ideas are this. Your job is to always, most math books would say isolate the variable. I just say get the variable by itself. That means the variable is on the left side or the right side, all by itself. There's nothing there. There's no pluses, there's no minuses, and there darn sure aren't any numbers. On the other side is the answer. Key idea number 2, if you decide to do something, you must do it to both sides. You don't have the choice of only doing it to one side. I don't remember if I showed this class last year. It turns out you can even do the wrong thing to both sides. Literally. If you were supposed to add 10, but instead you add 20 to both sides, you still get to the right answer. Eventually, I'll show you an example like that. But in algebra, you can do anything, including the wrong thing, as long as you do it to both sides and you do the math correctly. That's kind of a crazy thought. Oh, if you do choose to do the wrong thing, you just gave yourself extra work. You gave yourself an extra step. So if you're supposed to subtract 10, but instead you add 10 to both sides, oh, it'll still get you to the right answer, but you gave yourself 1 extra step. Typically, when a student does the wrong thing to both sides, they don't do the math correctly. And then the last one is, well, we got to get rid of things. You get rid of things by doing the inverse. I said the 4 inverses are, an inverse of addition is, the inverse of subtraction is, the inverse of multiplication is, and the inverse of division is. Yesterday we did addition and subtraction. Today we're doing multiplication and division 1 step. So it's baby steps. By the way, when I teach Algebra 1, which I probably will teach you next year, when I teach Algebra 1, I don't change the lesson. We don't do 2 days for 1 steps. We do it in 1 day. But then I spend 1 day on 2 steps, and then, multiple steps. We do 2 days on that. But Algebra 1, you're going to see these slides again. I do it for 3 straight years. Belief being by the 3rd year it sinks into your thick skulls. Okay, these are the inverses you guys just told me. And then lastly, once again, you won't find this in the book, but I call it the 4 steps to solve any equation. Kai, you're not paying any attention. Okay, write this down, Kai. These are the 3 questions in the one statement. So I will always say, hey, where's the variable? Is it by itself? You say it's on the left side. No, it's got a bunch of numbers attached to it. Okay. Then I say, well, what is attached? You'll tell me the numbers attached. And I'll say, well, let's get rid of one. And I'll say, which one do you want to get rid of? You'll say, I want to get rid of the 2. So I'll say, how is the 2 attached? You'll say addition, multiplication, subtraction, division. And then I'll say, well, then now do the inverse to both sides. Just like when we have positive and negative numbers, and I say same or different signs, add or subtract, big minus small, more negatives, more positives. I do the same thing to solve algebra. This is my script of what I tell to you. Kai believes he has it memorized.
Yeah, I do.
Go.
Get the variable by itself.
Kai said.
What is attached to the variable? It's something else. Oh,
Thank you, Kai, for
okay.
proving that
I
you
can
don't
do
know
it.
this.
Is the variable by itself? What is attached to the variable?
Now you're reading my slide.
No, I'm
So,
reading like this, and then
who will I be choosing to
Me.
say this in 2
Please.
days from now?
probably
Totally.
You better hope that Kai has this memorized by then.
Kai.
He doesn't have it memorized right now.
Because I
You
got
pick
this
me?
memorized. I got it memorized.
Yeah, welcome to Liberty Tree. You got lots of stuff to memorize here.
So sure
All
I
right.
am.
It will pay off when you are a Jeopardy champion in 10 years from now.
Wait, we're doing
Huh?
Jeopardy here?
Hi.
Oh my God, Kai.
Think it through,
What
Kai.
is he saying?
Think it through. If you ever go on Jeopardy, I'm claiming that you will have all this knowledge so that when they say the Constitution was signed in, oh my
17
word.
something.
Okay, at least you got the right century. 17.
76?
Oh God, no, that's when the Declaration of 1789.
Yeah,
Right?
Is it September 17th, I believe? I think it's September 17th.
And that's so dumb. Not knowing what that is.
Declaration of Independence was July 4th, 1776.
How did that fall?
Called gravity.
Gravity.
All right. So let's talk about solving one-step equations. Last class, we talked about solving equations that involving adding and subtracting. Same questions I always ask. Where's the variable? Left side. What's attached? A 2. How is the 2 attached to the x is attached by addition? We do the inverse. The inverse of add 2 is subtract 2. We subtract 2 not from one side, but from both sides to keep it balanced, right? 5 minus 2 is 3. Could you like just chill for a second?
He's moving my desk too.
I know, you're like a hurricane, right?
Yeah. He keeps moving so I can't see the boy.
Hurricane Landon. All right. 5 minus 2 is 3. I said, are you listening? I said that this step is, although I will show it for the first couple of days, eventually I will stop showing this step and just simply say x equals 3. You are not allowed to skip this step that says minus 2, but you want to skip the step that says x plus 0 because you're like, yeah, well, 2 minus 2 is 0. And 0 added to anything, that property of 0 or the addition property of 0 says nothing changes. Okay? All right, today we're going to be doing ones that involve multiplication division. So pencils down, look at the board, same questions. Same questions. Abby, where's the variable, left or right side? I'm looking at just the right side. Left side's dead to me right now. On the right side, is anything attached to the variable? 2 is attached to the variable, is attached to b, right? Mathematically, how is 2 attached to it? How do we get rid of multiplication? Because division is the inverse of multiplication. So what are we going to divide both sides by? We're going to divide both sides by the number you're trying to get rid of. Occasionally I have kids who want to go to the other side. We're not trying to get rid of 10, we're trying to get rid of 2. So for those of you that have not had me as an algebra, pre-algebra teacher before, look at the board. This is how we show to get rid of multiplication. We do it with division. We don't write division symbol, the minus sign with the 2 dots. We write a fraction bar. We show that I'm dividing both sides by 2. You see what I did there? 2 is attached by multiplication. The inverse of multiplication is division. So we divide both sides by the number I'm trying to get rid of, which is 2. All right, here comes the magic. What is 2? Fraction bar means division. What is 2 divided by 2? 1. This thing that we do in algebra, which is called canceling, this slash that we put through those numbers is actually the number. It's the number 1. Every math teacher said cancel the numbers. Here's what they forget to tell you. That red slash right there, or black slash for you, is literally you're changing it to the number 1. You're reducing the fraction. 2 divided by 2 is 1. Right? What's 10 divided by 2? Once again, this is an optional step. So that slash turns into 1, but what's 1 times anything? Itself, which is why most kids skip this step and go right to the answer. But what you're not allowed to do is you're not allowed to go from that to p equals 5. You must show me that you're dividing both sides by 2 and that you cancel. Okay? That step right there that I just showed you, this one right here, you may skip. I will show it to you for a couple days and then stop doing it. No. All right. Yesterday we learned about this thing called a check step. So a check step is you take the original equation, which was 10 equals 2p, and we take our supposed answer, which we believe is 5, and we throw it back into the equation. And we see if the left side equals the right side. Hey, 2 times 5 is 10. Check steps are optional. Seems ridiculous to do for a 1-step equation, but it's not ridiculous when it's a 3 or 4-step equation. You can literally check to see if you got the right answer. Called check step because for check mark. All right, here's another one. All right, Angelina, where's the variable, left or right side? Well, I'm looking at just the left side. Is the variable by itself? What's attached to it? How is 6 attached to x? How do we get rid of multiplication? What are we going to divide both sides by? The number that we're trying to get rid of is 6. New kids, do you understand your division? The fraction bar is the division symbol, right? For the new kids that had this last year, is this how your math teacher showed you to do it as well?
Yeah.
Right, writing that division symbol and then 6, there's just no room for it, right? Okay, what's 6 divided by 6 on the left side?
1.
It cancels. That's what that slash means. It doesn't mean it turns to 0. For addition, subtraction, yeah, it means it turns into 0. But canceling means it turns into 1. 1 times x is x, and negative 42 divided by negative 6 is negative 7. Therefore, x equals negative 7. Questions? Okay, let's do one. Box 3, here we go. How can I make this more challenging for 8th graders? Negatives, right? You got to make sure you don't drop negatives. Got to make sure you don't drop negatives. Genevieve, where's variable, left or right? Left. Okay. Left side. I'm just looking at the left side. All right. Stop what you're doing, look at the board, or look at your paper for box 3. Occasionally I get students, when they look at that, they're thinking subtraction. I know why you're thinking subtraction, right? Because it literally says subtract 3k. Or maybe it says negative 3k. It means both. Okay. I know why they think subtraction, but technically, the number attached to k is, the number attached to k is, it's not a 3. The number attached to k is negative 3, and negative 3 is attached to k by multiplication. So I don't understand why some kids want to add 3 to both sides. Did I just confuse somebody? I understand why you might want to say you want to add 3, because it looks like it means subtract 3. Doesn't mean subtract 3, it means subtract 3k. So technically it's a negative 3 attached to k. So this one I'm going to divide both sides by negative 3. If you're going to make a mistake, it's going to involve negatives. What's a negative divided by a negative? So the negative 3's cancel and turn to 1. What's negative 42 divided by negative 3? Positive or negative? That's why the answer is k equals 14. Questions? All right, do these 4 all by yourself. Box 4.
I might have a negative
Okay,
problem in there.
you literally didn't listen to anything I said.
I didn't.
I said, how are we going to write the division symbol?
Wait, so
How are we going to write the division symbol? Okay.
now. Wait, so we don't want to divide it?
How is it attached?
Oh. I didn't think about fractions.
Yep.
How about now? Oh, divide.
Well, my only issue was the division symbol. The rest was fine.
What's good? What's 96?
6 goes into 9 how many times?
2, 1.
With how many left over?
Can you try to get the right answer in time?
I think so.
2,
How about
3.
3? So 36. 6 goes into 36.
4,
How about 6?
6.
So 1 and a 6 turns into, there you go. I don't know if it's positive or negative because I wasn't looking at the problem. Anybody need help? Hannah, you good? Have you done this before, Hannah?
Yeah, I've done it before, but I did that at dividing.
So what should you have in front of your face right now? That's what I would. Genevieve?
So if it's 2 negatives, it equals a positive?
If we're talking about multiplication or division, always.
Okay.
We're talking about adding and subtracting, it sort of depends on what the numbers are. What? No, it doesn't. 4 goes into 42. Wait, it's a 14, not 4. 14.
Yeah.
How about 3 times?
No.
3 times 4 is 3 times 4 is 2 carrier 1. 3 times 1 is 3 plus 1 is 4. It's 42. All right, Jaden, upper left, final answer.
So left, x equals 16.
Yay, nay?
Yay.
Yay.
No, I thought.
Yeah.
Priscilla, bottom left, what you got?
C equals 16.
Because a positive divided by a negative is a positive.
Oh, C equals negative.
Okay, what did I say your mistake would be?
Dropping.
You're going to drop a negative, right? You got to slow down in pre-algebra, algebra 1. It's really common. It is really common. I always take away 1 point if you drop a negative, right? You end up, a lot of people giving them, typically 8th grade is when we find out who are the negative droppers, right? And then that kid, it will be a whole year of dropping negatives. And then they get to algebra 1 and they're like, hey, I don't drop the negative anymore. But usually, just like I subtracting positive negatives, it takes some 8th graders a while to recognize when they are, when they're not dropping negatives. Christian, upper right, what do you got? How much? 2 equals 3. Okay.
Oh, yeah, what's 3?
Right, we did this one together.
I thought it was 2. Oh,
We did this
yeah.
one together. Right, you got the last one?
Yeah, C equals negative.
Because a negative divided by a negative is a negative.
Positive.
So I've already identified 2 of my negative droppers, right? Try to just convince yourself that I won't make that mistake again, okay? Because it's giving away a lot of points, right? You're losing a whole point just for dropping a negative, right? Just pay attention whenever there's negatives involved, and hopefully you can keep yourself from making those silly mistakes. And they are silly mistakes. Okay, stop what you're doing, look at the board. First weird one. Okay, this is usually where I will see lots of mistakes. Okay, so let's see. Where's the variable class, left or right side?
Left.
So I'm just looking at the left side. Is x by itself?
No.
What's attached to it? 9. How is 9 attached to x? How do we get rid of division? So here's the issue. We need to multiply both sides by 9. Well, it's not a question on the right side. We put a dot 9. That's easy. What some kids will do is they'll put dot 9 right there. What's 9 times 9? So what you're really multiplying, if you put the 9 on the bottom, is 1/9. I didn't say multiply both sides by 1/9. I said multiply both sides by. So how do you write 9 as a fraction?
1 over 9.
You just said literally what I said not to
9 over
do.
1. 9
Thank
over
you.
1.
So we need to multiply both sides, but the left side is a fraction. So it needs to be written as a fraction. You're like, why can't I just put a 9 next to the x? Okay. Well, technically you are still writing 9 over 1. You just chose not to write the over 1. If you choose to only write the 9 right here, I still need a dot there. And I need you to extend the fraction bar like that. You need to show me that you put the 9 in the numerator. Okay? I'm always going to write as a fraction because you'll see why when we do a more complicated one with a more uglier fraction. With an uglier fraction.
So then what is like
Well, what's 9 divided by 9?
Oh, 99.
Oh, I got to put my other dot 9, sorry. 9 divided by 9 is
99. 1.
what?
1.
1. Okay. 3 times 9 is,
27.
so therefore x equals,
27.
yes?
Yeah.
Okay. The mistakes that I will see, once again, is they'll put the 9 on the bottom. You just turn that into x over 81, right? The 9 has to go on the numerator. In other words, it needs to be written as a fraction. Some kids will never write as a fraction, and that's okay, as long as they extend the fraction bar over to show me that the 9 is in the numerator. I can live with that. I always write as 9 over 1 because you'll see why we have an uglier fraction. All right. Whoops, sorry. What's attached to x? Not a 4. How is the negative 4 attached to x? So how do we get rid of division? We got to multiply both sides by, well, there's a problem over here. If you put dot negative 4, guess what it looks like? It looks like 5 minus 4, right? If you're not paying attention. When it gets more complicated, maybe you won't catch that. So I would always recommend, instead of putting a dot, maybe put parentheses, right? See what I mean? I'm not saying you can't put a dot negative 4. It's just that if you put parentheses, you're reinforcing. Oh, by the way, if you put parentheses, you don't need to put a dot either. You can just put parentheses negative 4. Okay? Negative 4 divided by negative 4. Okay, and 5 times negative 4.
Negative 20.
Positive 20.
Because a positive times a negative is a positive.
Yeah.
No, no.
Yes. Because we're positive and negative.
You're thinking addition, subtraction.
Oh.
He would be right for addition, subtraction. That would be a positive 1. But we weren't adding or subtracting, we were multiplying. Okay? So x equals negative 20. All right, box 5, let's do it together. Here we go. Variables on the right side. What's attached to x?
Negative 7.
Negative 7. Negative 7 is attached to x by division. Aiden, how do we get rid of division? Multiplication. We're going to multiply both sides by negative 7. Ooh, ugly.
Dude, there's no point.
What are you guys yammering on about?
He's saying it's not.
Wait till we get there.
All right.
Dude, it's not a negative. Oh.
Negative 7 divided by negative 7. Cancels. Technically, it's 1. A negative times a negative, Kai, is a?
Negative.
You said both answers.
Negative.
Positive.
Positive.
Now you're just saying things because everyone else is saying things. I would recommend on your sheet of paper you have the rules for multiplication division. All right, positive 14, so x equals 14. We okay?
Gosh, Jackson, he's throwing me off.
Well, then maybe you should listen to Jackson.
What do you think? Okay.
He's like, all right, so it's negative
You have 4
14.
problems. Do them, box 6, and then we'll do the challenging ones.
Oh,
These are not challenging.
I do these. I forgot it.
Landon's forgotten how to do the challenging ones.
Dude. Stop. Can't give me the answer. Negative. Positive.
Hi.
Hi, stop it.
You
Why
better.
are you giving us all a headache?
No, he's giving me a. You're giving me a migraine.
Jenna, you already done? Work. Pencil in your hand, work.
Oh, that's 42, not 40. Negative 40.
Jenna, work. Thank you.
Is that how you do it? Yeah, please.
A negative times an
Oh, yeah. It's so difficult.
I want to put this to the other side.
Okay.
I want it on that side.
16, negative 16.
Anybody need help?
Nah.
Hear about that?
Yes, possible. What's wait, oh yeah, wait. What's the positive times the negative?
Abby, you good on this?
Bruh, how?
Amanda, you good?
I did it.
Don't say yes if you mean no. Usually kids do much better on the multiplication division than they do with add and subtract.
I got it.
All right, here we go. Gabby, first one upper left. What's the answer? Final answer? No. A equals 42. Very good. A equals 42. All right, Callie, bottom left. Negative.
Oh, I see how you do that.
What did you do to both sides? Negative. Negative 16 equals D. All right. Christian, upper right. Because a negative times a negative is a negative. All right.
Oh, wait, no.
All right.
They're so stupid.
Dropping negatives is easy to do.
Let's go. Actually,
All right, Prudence, last one. D equals negative 1,000.
I got that one right.
All right. What? Jaden? Time out. I can't hear Jaden.
Can I throw something on the board? No.
Just tell me what you want.
Okay, so I figured out another way to do this.
To do what?
Wrong. Stop trying to.
Hey, just let him talk.
I figured out another way to do problems.
Okay, tell me.
So it says 6 equals A over 7. So then you put 7 equals, so like 7. You multiply the whole number times the denominator. Put that over the.
Let him talk. Keep talking.
Over the denominator, and that gives you the answer right off the bat.
Well, that's what we're doing, by the way. We're multiplying both sides by 7.
I know, but like, I put it in a fraction.
So did I. Put 7 over 1.
No, he means like the A. He means A. But we like.
Tell me what you want me to write.
40, 42,
Where did I get a 42 from?
6 and 7. Multiply together, 42.
Oh.
So you want me to literally do what I just said?
No, he doesn't want you to write the fractions. He just wants you to look
Yeah,
at
but you
that.
got to get rid of the number that's attached to A.
You do it.
Yeah, but you're just making this number 42 up.
Easy. No, I'm not.
Well, if the 42 came from somewhere then.
Multiplying
He's
6 and
multiplying.
7.
Right. So you want me to write a 7 next to 6.
No.
No, he doesn't
No,
want you
No.
to-
6.
Yes, I want you to
Like
write
this,
it.
like this.
You want me to write 1 over 6? What do you want me to write?
I wonder.
If you say 42, I'm going to say, where did 42 come from?
6 times 7 over 7 equals
6
A
times
over
7 over 7.
No. You try to.
He's talking about this right here.
He's saying don't.
You said 6 times 7 over 7. I did.
Over, no. 6 times 7 over 7.
I did.
No, both of those numbers over 7.
Oh my god. Shooter.
No, not 77.
No, to get like. put
You
the-
said write both numbers over 7. I just did.
One
Okay, so
fraction
put a
bar,
line.
1
1 second.
fraction bar.
Yeah,
Plus
put-
7.
Times 7.
Yeah.
And that equals 42
So
over 7.
here's your problem. When you put that 7 on the bottom, what did you just do to the left side? You just divided it by 7, so I need to divide the other side by 7. And then I got to multiply by 7 because I multiplied by 7. That looks crazy complicated.
I made it easier if we don't follow.
You made it much more challenging. Because Jaden, here's the next problem. 6 equals 4 1/3 A. Now what?
Divide both sides. No.
Now what?
You're trying to do a mixed number.
Right. You mean a proper fraction?
Yeah.
All right.
This is so
Jaden, I highly recommend you don't do that technique. You do it my way. Highly recommend.
I do it for some.
All right. Some ones that will cause you some problems. Everybody stop and do look at the board. Some ones that will cause you problems is this one. What's attached to X? So if you decide that what's attached to X is 7, then you would multiply both sides. Don't listen to Jaden. You multiply both sides by 7. What would you be left with?
3. Tell me now.
You'd be left with 21 equals
Negative X.
negative X. So here is my suggestion, and that will turn that into a 2-step equation. Here is my suggestion. The easiest way to deal with this one is to take the negative, and remember, you had a quiz on it, or the test, sorry. If the negative is in the middle, you could also put it on the
Bottom.
or the top, which is the easiest one for this problem.
The bottom.
Put it on the bottom. So my suggestion, remember, because fractions can be written 3 different ways. Shame on you if you missed that on the test. Some of you did, right? You can put the negative, if it's in the middle, either on the top, the middle, or the bottom. If we place it on the bottom, it's not that you can't put it on the top and the bottom, but if you put it on the top and the bottom, what are you telling me? That it's positive. Negative divided by negative is a positive. Okay. By the way, we will use this technique in Algebra 1 occasionally. We'll put the negative on the top and the bottom.
Why would you just put positive?
And it's a good question, but I'll have to show it to you in Algebra 1. All right. So if you have a negative in the middle, my suggestion is to put it on the bottom and then solve it the appropriate way. Okay. All right, do box 7, please. It's a combination of multiplication and division. It's a combination of multiplication and division. Do box 7, and then we'll do the last ones and we're done.
This is so confusing.
What part's confusing? Where's the variable, left or right side?
No, like the negative stuff.
Negative divide. That's why on your paper you need to have negative divided by negative is a positive. Same signs positive, opposite signs negative.
Okay.
Not the same rules as addition and subtraction.
Oh.
Is everybody okay? You can get this started?
This is the way.
Which one?
First one.
Which one? Upper left, upper right, bottom left, bottom right. Upper left,
Yeah.
bottom left. Put the negative on the 7. Another negative 7. Right. Yeah.
How did you get 12? That doesn't make any sense.
Well, then maybe he's got it wrong. You do it your way. Let him do it his way. We'll figure out who's right or wrong. Do it your way. He does it his way. We'll figure out here in a second who's got it right.
84. Figure out what 7 times 4.
What number are you trying to get rid of? How is 7 attached to A?
Why?
How is 7 attached to A?
Oh, multiplication.
So we need to
Divide.
both sides by 7.
Yeah, but 84.
No,
You're thinking of this backwards. It's not 84 into 7. It's 7 into 84.
Oh yeah, still, but like
7 goes into 8 how many times?
1,
Wait, how many left over?
0.
1 times 7 is?
Oh, there it is.
All right.
You think it's
I'm going to miss when you're not my student anymore, Kai. I'm really going to miss it.
we're all gonna miss.
And I'm not being sarcastic.
Are you gonna?
We already
Because
missed Shepherd.
I can count, teachers live for the moment,
Are you
right?
leaving?
And I get that like 6 or 7 times every class period of time.
Do you miss Shepherd?
well, that.
Do the work.
Let's see, how many times did you say
It does it 6 or 7 times every class period. All right, it appears that the majority of the class is done. David, upper left, what do you got? Final answers. You didn't hear David, but he said A equals 12. All right. Go ahead. Say the full answer. T equals negative 1/4. Very good. All right.
I'll do this one.
What do you got? Go. Why not? You sat there while we were talking. You did nothing. Come on. Do your job. All right. What do you got, Lucia?
I'm still working.
Tell me what to do. I'll do it for you. Tell me what to do to both sides.
So
What's attached to the variable?
13
How is it attached?
fractions would be division.
How do we get rid of division? What are we going to multiply both sides by? And because this negative is in the middle, it's easier to bring it down to the 13. We're going to multiply both sides by negative 13. A negative times a negative is a, so we just need to know whatever 13 times 78 is. Well, 10 times 78 is what, 780, and then 3 times 78 is, okay, I can't do that in my head too quickly. 3 times 8, 24, 4 carry 2, 3 times 7, 21 plus 4, 2. Oh boy, that's a hard one. Here's your answer.
See, I got it right.
Oh, I'm just saying, for me, I would not try to do 13 times 78 in my head. Right? I might do 10 times 78 in my head, but what? Well, maybe I'm wrong. Maybe you're right. Let's see.
No, he's wrong.
78 times 13. 3 times 8 is 24. Carrier 2. 24. Carrier 2. I wrote this backwards. 3 times 7 is 21. Plus 2 is 23. There was my mistake I made the previous time. 3, 9 is 0. I got an 8. That's 7. That's 4, 11, 9, 10. 10, 14.
I got that right.
All right.
No, he's not wrong.
Last one, F equals negative 20. Yes.
I have no
Time out. I can't hear you.
on
Guys,
on the X over 13. I have no idea what I decided that one.
do you agree that we are going to multiply both sides by negative 13? Okay, then the only argument is that your multiplication is wrong. But I'm saying the key point here is realizing that you got to multiply both sides by negative 13. Okay. Well, we're not going to spend time on that. I'm just saying your mistake is just the multiplication. But your process was correct. All right. Quick note on canceling, because I always hear this from students. Look at the board, put your pencils down, look at the board. What are we going to do to both sides, the one on the left?
-6.
This is not canceling. This is just subtraction. So 6 minus 6 is 0. Over here, to get rid of the 6, we are, in fact, dividing by 6. Right? This right here is the one that actually does turn into 0. The one on the right, it doesn't turn into 0. It turns into 1. The one that turns into 1, we deem, mathematicians, as called canceling. This one on the right is called canceling. We're not done. Why are you packing up? We've got the hardest ones left. That is called canceling. All right, here we go. Last big thing, fractions. Hey, this one's easy. What do we do to both sides? We multiply both sides by 2. Okay, notice I didn't write 2 as 2 over 1 now. This is the one. Now you got to pay attention. We're going to stay here till we get this one right. Okay, here we go. What is attached to x?
1/5.
How is 1/5 attached to x? How do we get rid of multiplication? All right, hold on. Hold on. So we just decided that we're going to divide both sides by 1/5. Yes?
Yes.
Last chapter. How do you divide with fractions? So the question is, what are we copying? What are we flipping? Are you ready? The one that if you listen carefully, you will never make this mistake. The one that you will flip is the number attached to the variable x. So that's what we're going to flip. We're going to flip the 1/5. In other words, we're going to multiply both sides by 5 over 1. I'll say this again. You decided that you're going to divide both sides by 1/5. That's copy, dot, flip. The thing that you're going to flip, you're not listening, you're packing up. The thing that you will always always flip. It's not the one that doesn't have the variable. It's the one that does have the variable. One more time. The thing that you flip is the one attached to the variable. So I multiplied both sides by 5/1. Why didn't I write 5/1 on the right side? Not a fraction. Okay. All right. See you guys later.
I want to see my quiz.
I haven't finished grading.
I memorized the poem all night last night. I fell asleep.
All right, e-learners, any questions? If not, I will see you tomorrow.